Well, this was an unexpected video. I heard that some students were in distress over some empirical formula calculations. And so, if you want the courage, the will, the power to master empirical formula, stay tuned.
Fear not, citizens! Hope has arrived! Because I am here!
Here are the retrieval questions for this lesson. You know what to do. RAM, RAM, RAM stands for relative atomic mass, and this is the massive number on the periodic table. The RAM of carbon is 12. RFM is the relative formula mass. Sodium chloride has a relative formula mass, a RFM of 58.5. A mole of particles is equal to 6.02 times 10 to the 23 particles. If you found any of that confusing, I suggest watching this video I did on RAM and moles before continuing with this video because it can get very confusing. Empirical formula is the simplest whole number ratio of atoms of each element in a compound. To illustrate this, let's look at ethane. Counting the carbons and hydrogen, we see that the molecular formula is C2H6. As you can see from the molecular formula, this gives you the total number of atoms of each element in a compound, but this isn't the simplest ratio. Dividing both numbers by 2 gives us the empirical formula, which is CH3. Now do the same for butane. Write out the molecular and the empirical formula. The molecular formula is C4H10 and the empirical formula will be C2H5. Let's go through some questions now before we move on to the harder bits. This question gives us a displayed formula for a molecule, and just like our previous examples, you need to write down the empirical formula of this substance. First step would be to list the number of atoms of each element that you have. We have 2 carbons, 4 hydrogens, and 2 oxygens. To get the simplest ratio, we can divide by 2 to give us 1 carbon, 2 hydrogens, and 1 oxygen atom. Writing this out would give us the empirical formula CH2O. You can have the elements in any order you want as long as you have the right amount of each element. Also, make sure you write your numbers as subscript, not regular numbers like this, or not superscript. That's when you write it on the top, like when we write charges. Don't do that. Write your numbers as subscript so they go lower. You won't get the mark if you do that. The next question is asking us for the empirical formula for this molecular formula. If you're like me and you're terrible with maths, then you can work backwards. For example, option A is C2H4. If we divide the number of atoms from each element, we should get the same number. We have 12 carbons in the molecule and 2 here. So 12 divided by 2 gives us 6. 6 times 4 hydrogen gives us 24 hydrogen. So A is in our answer because if you have a look at the top at our molecular formula, the hydrogens should be 26. So you can spend some time now going through each one and trying to work out what the correct empirical formula is out of B, C and D. The answer is D, and here is the working out. Now one more task before we move on. Use the information we've looked at now to find the empirical formula for salicylic acid, which is this formula here. We have 7 carbon atoms, 6 hydrogen atoms, and 3 oxygen atoms. Here is where a few of you may have made a mistake. Since this is already the simplest whole number ratio, this is the empirical formula. C7H6O3. Again, the elements can be in any order as long as you've got 7 carbons, 6 hydrogens, and 3 oxygens. Again, the numbers should be subscripts, okay? Not superscripts or regular numbers. Here are 2 mistakes that students have made with that question that we just looked at. Even though the student on the left had the right number of elements, because they added the plus signs, they don't get the mark. You don't put any plus symbols in between your formula. The one on the right had the right calculation, but I think because they thought that the empirical formula always had to be smaller than the molecular formula, they divided the hydrogen and oxygen by 3. Don't make these simple mistakes, okay? Okay then. It's the moment you've all been waiting for, so I'll stop teasing you and I'll get straight onto it.
You naughty, naughty, you teasing me, you naughty, naughty.
When you're asked to calculate the empirical formula, you will be given something like this. A scientist found that a compound contained 22.8% sodium, 21.8% boron, and 55.4% oxygen. Use the percentages to calculate the empirical formula of the compound. You're then given the relative atomic masses of boron, which is 11, 16 for oxygen, and 23 for sodium. Here is the structure I recommend that you should follow. First, you write out your elements on the same row. So you can see on the top row there, I've got sodium, boron, and oxygen. To save me time, I've just written the symbols. Then you write the corresponding percentages. Then the RAM, which you're usually given, but if you're not, just look at your periodic table at the larger number. At this stage, we divide the percentage by the RAM, the RAM. We will then divide each of our answers by the smallest number from our previous answers. Then we have our ratio. I know that all sounds like gibberish right now, so let me apply these steps. First, let's fill out our percentages. Look at where I got these from the question. 22.8% sodium, 21.8% boron, and 55.4% oxygen. Then I write down the RAMs. The next step, as you can see, we have to divide the percentages by the RAMs. And what does that give us? So sodium is 22.8 divided by 23, which is 0.99. I had more digits in my calculator, but 2 decimal places is a good practice. Do not round up your numbers here, okay? Do not round up your numbers. Doing the same for boron gives us 1.98 and oxygen is 3.46. The next stage is to divide by the smallest number. So we have to look at our answers and locate the smallest number, which is sodium 0.99. That means that we have to divide each one by 0.99. For sodium now, 0.99 divided by 0.99 gives us 1. Boron, 1.98 divided by 0.99 gives us 2. And for oxygen, 3.46 divided by 0.99 gives us 3.49. The oxygen is only 0.01 away from being 3.5, so we can change that to 3.5. It is important not to round all the way up to 4 here. There is just one step left. We have the ratios now, but remember the empirical formula is the whole number ratios, alright? So we need to multiply all of these numbers, 1, 2 and 3.5. We need to multiply each one by 2 because we want to turn that 3.5 into a whole number. So what does that give us? 1 sodium times 2 gives us 2 sodiums. 2 borons times 2 give us 4 borons. And 3.5 oxygens times 2 gives us 7. And this is our empirical formula. Sodium, boron and oxygen, Na2B4O7. I definitely recommend using the timestamps to skip back to the start of this calculation and try to write out the steps I've given you, okay? And then getting comfortable with that before you move on. In this question, you may notice that you've been given grams instead of percentages.
What nonsense is this?
Don't panic, don't panic. Just treat the masses exactly the same way we treated the percentages. So write out the grams here and then divide the grams by the RAM. It's exactly the same step, just treat the grams and percentages as interchangeable numbers. Now, pause the video and calculate the thing. From the question, we have 0.60 grams of carbon, 0.15 grams of hydrogen, 0.40 grams of oxygen. And then I add them into my table. The RAM of hydrogen is 1, the RAM of carbon is 12, and the RAM of oxygen is 16. And I add those to my table too. Gram over RAM for carbon is 0.60 divided by 12, which is 0.05. Now for the hydrogen, 0.15 divided by 1 gives us 0.15 for the hydrogen, and 0.40 divided by 16 gives us 0.025 for oxygen. Again, the next row, we have to locate which number is our smallest number, which is the 0.025 from the oxygen. Doing that for each of our calculations now, dividing each number by 0.025, that gives us 2 for carbon, 6 for hydrogen, and obviously 1 for oxygen because it's the same number. We do not have any decimals here, so these are the whole number ratios, and therefore this is the empirical formula. C2H6O. Notice that I don't write the 1 next to the oxygen, just like when you write in regular formulas. Don't write the 1 next to it if it's just one atom. Now try this one. Try and complete it without me showing you the table. If you get this, then you've patterned the whole empirical formula thing. Trust me, believe in yourself. If you need to go back and watch what I've done before. Try and complete this one by yourself. This is a pretty difficult one, so if you've got this, you're good to go. So our empirical formula is Pb2Cl2CO3. Just before you start celebrating, there's one more thing I want us to look at. You may get this question, this style of question, where you have to work out the molecular formula from the empirical formula and the relative formula mass. You've got the empirical formula here, which is CH2O. You're also given the formula mass, which is 90. First thing you need to do is work out the mass of your empirical formula, that's CH2O. What is the mass of that? If they don't give you the rams, we're not given the rams in this question, you can just look at your periodic table and look for the bigger numbers. Those are the relative atomic masses. The empirical formula has 1 carbon, 2 hydrogens and 1 oxygen. Subbing in our numbers, our rams, we get this. Our empirical formula, the mass of our empirical formula is 30. The next thing we need to do is we need to divide the relative formula mass that we were given in the question by our empirical formula, because we want to find out how much larger that relative formula mass is. And if we do that, the multiplier is what we'll find out. So the relative formula mass, which is what we got in the question, and the mass of the empirical formula, plugging in our numbers, the 90 from the question, the 30 that we just worked out, that gives us 3. So the relative formula mass is 3 times larger than our empirical formula. That means that we have to multiply everything, every atom in our empirical formula by 3. And when we do that, what do we find? We find that B is actually the correct answer, because that is 3 times each one. So we've got 3 carbons, 6 hydrogens and 3 oxygens, which is exactly 3 times bigger than our empirical formula. And there we go, lesson is done. If you don't have them already, check the descriptions to get my flashcards and other stuff like my revision timetable as well, which you can customize to your own preference. Use the timestamps if you need to brush up on some bits that you were working on but you're still kind of shaky on. Let me know if you need any more help, and I'll catch you guys in a bit.